My name is Sean Zimmerman,
And I'm Terrence Prettyman.
and this is our project, a high-efficiency crank-powered lantern and USB charger.
And so the idea for this project is if you're in some sort of emergency situation or you need light, it's basically a crank flashlight where you can crank, and that's going to store enough power that we have in rechargeable batteries to give you light at the output from LEDs. And this, the neat thing about our specific design is not only does it power a flashlight, you can power any USB device. So right here we have hooked up an Arduino. So our flashlight also can charge USB, so if you have a phone or some other device that you want to charge as well, you can use this to charge that as well as having a flashlight.
The main thing that we were aiming for in this design was efficiency. So the runtime of the system, if you're not using the USB charging, the lights alone should last for approximately 10 hours on fully charged batteries. If you are USB charging, we estimate a runtime of 5 hours. The system is designed to be flexible in that you can either use rechargeable batteries, nickel metal hydrides, and crank the system up and use them as normal rechargeable batteries. However, at the same time, you can also drop in any AA form factor battery that's fully charged from the store and run the entire system off of that. So if you did want to just buy pre-purchased batteries and use the system as just a USB charger and flashlight, you're fully capable of doing that.
And so the neat thing about our system is that basically it's kind of easy to use. The hardest thing probably is just making sure you're in the right mode to run, but it shouldn't matter how hard or soft you crank. It's very hard to not crank hard enough, and if you crank too hard, that's okay as well. So the idea is that we don't know the input that we're coming in, so everything in our circuit has been regulated and referenced. So it doesn't matter how hard or soft you crank, the batteries are always being charged by a constant current of 100 milliamps, and we're always getting 5 volts at the output, regardless of how hard you crank. And so that was probably one of the biggest challenges, is that we don't actually know our input. So we have to make it so that we do know what's going on afterwards, what comes in here. And so right now, everything fits in here. We have a form factor of a AA battery, and as you can see, the biggest thing is probably the motor. And of course, in all actuality, this would just be closed, and you would just see the top with the lights. And
On top, there would also be a spreader because this entire system is designed to be a lantern. So this project was a joint with the mechanical engineering departments. There are 2 mechies on this project as well. They designed the rapid prototype material, the overall shape and design of the system.
they
But
also did the gear ratios for the motor.
so the completed design, which you'll see tomorrow at the Mechie Fair, will have a light spreader, a conical light spreader on top. It also has a cap on the bottom so the device can actually be stood up.
So that the handle, as you can see, the handle's kind of in the way. You can just, put it on a stand and have light around the campfire if you so desire.